All right, it's recording. Perfect. So welcome back. Now we are back to a practical part. So SQL, select from where, and so on. Everything I'm going to show you now is things you can do in the Jupyter notebook and just type the query, see what it does. So this is actually the fun part of this course, and this is really the practical part that you'll be able to use in all your projects if you have projects, and also in the future. So we've seen the data definition 2 weeks ago. The data definition, remember, it means you create a table, you say which columns you want, you say the domains that you want in that table, you specify a few constraints. Do you allow nulls? Do you not allow null? Do you want unique values in one or multiple columns? I also showed you how to declare a primary key. I showed you how to declare a foreign key that references a primary key. So these are all basically, that all has to do with data definition. I explained a bit of data manipulation, but something basic, just about inserting data, deleting data, updating data, right? That would be considered data manipulation, right? So again, now you know how to do it with SQL. If I ask you to define schemas, create tables, normally, that you know how to do. Who knows how to do it? All of you, right? Okay, very good. Now, data manipulation is when you actually manipulate the records themselves, right? So we already know how to insert, delete, and update. That we've done. Now comes the interesting part with querying the records. What we're looking at is basically an implementation of the relational algebra, but with the SQL language, right? So this is the focus on today. So the relational algebra, as you recollect, is a theory. It's a theoretical way of manipulating the tables as mathematical objects. Now you have this overview on them, but now this is all familiar to you, right? We have union, intersection, subtraction with sets of maps. We also generalize it to bags. Selection, that's sigma. Projection, that's pi. Renaming queries, that's rho. Shuffling queries, grouping is the gamma. Sorting, I just mentioned it. We didn't give it a name. Cartesian product, that's the cross. Natural join, that's the cross with the 2 additional vertical bars. And the theta join is the same, but with a description of the criterion for joining. That's called the theta join. So let's do it with SQL. SQL, as you know, is a declarative language. You don't even need to explain or to implement how the details of a selection or the details of a projection look like. You just declare that you want a selection or a projection, and the PostgreSQL is doing it for you. It is set-based, meaning that you can manipulate billions or even trillions of records at the same time. So it feels extremely powerful when you do it. I don't know if anybody used, for example, BigQuery with Google, but you can literally have data in trillions of records, and with just a few lines of SQL, you can manipulate these trillions of records on top of machines, right? So this is extremely powerful. So I already told you SQL, SQL, it's all the same. There's the 2 ways to pronounce it. But let's move over to the simplest hello world query. You know, hello world is what we call the simplest you can do with a language. So the simplest query you can have with SQL is to just return the contents of a table. That is select star from persons, and it just returns the table. This is extremely useful because that you will put all the time in your Jupyter notebook. This is when you want to view what a table looks like, right? So this is really a very useful query that you will use in the notebooks. Okay. Typically, in fact, if you put it in a notebook, it might not display the entire table. It might only display some records of the table, but it's not going to crash your entire screen. I will show you later how you can limit the number of records that you want to see on your screen, right? But select star from persons basically outputs the whole table called persons. Now we'll see that all the tables that we will create with our queries, they won't really have a name. right? So we have tables with a name. We gave the name with create table, right? You say create table, then you have the name of the table. These are the tables that are persisted, that are stored on the computer forever, right? You store them. But the tables that you see on your notebook, they will disappear as soon as you close the notebook, right? It's not stored anywhere. They just temporarily appear on your screen while you are manipulating the data. This is why I'm saying there's no name, it's not stored anywhere, right? It's a temporary table that you see on your screen. Okay, so select star from persons. I will show you a bit the notion of a query plan, which is basically the relational algebra behind the SQL query. It actually is done by PostgreSQL, but you don't see it. It's done in the background, right? But this one is really trivial because you just output a table. Now let's move to projection. That's the letter pi, the Greek letter pi. So remember that the projection needs a certain number of columns that you project to. So here we have a relation R and we project to columns A and C, and we get a table that has columns A and C. So how we do it in SQL, I'm going to take this same table here, like this. Select first name, birth date from persons. So what I did is that instead of the star, I have a list of columns. So select first name, birth date from persons. That is going to output another table with only 2 columns, first name and birth date. Okay. So this is how you do a projection. And here I have my word of warning because this is when it can be confusing. The projection is done after select. And that kind of doesn't sound logical, right? Because select, you would think selection. But no, it's really the projection that is done after select. Okay. So this is a projection. This is another one where you project on 2 different columns, but you can see here that there's duplicates. You can see if you look at original series and birth date, in that case, James Kirk and Spock have exactly the same. So you will notice if you do it in your notebook that the duplicates will not be eliminated. What does that tell you? It tells you that PostgreSQL applies a back semantics, not a set semantics, but a back semantics if you do this. So it's not going to eliminate the duplicates. If you want to, you can, but then you add distinct. Select distinct original series birth date is going to get rid of the duplicates. And now you're back to a set of records. Okay. Okay, so now the query plan would look like this. You basically have the from basically gives you the table, and you apply pi with the select clause and the name of the columns that applies pi to the table and selects projects to specific columns. Okay, so you can also represent it like this. That's called also an abstract syntax tree or an expression tree. So this is called the query plan. And that you don't need to worry about because PostgreSQL does it in the background. If you enter this in your Jupyter notebooks, then PostgreSQL will automatically figure out it has to apply a pi operator in the background. Okay, let's move on. So now we have renaming. Renaming is the letter row. So you want to rename, let's say, column A to column D on R, like this. Right? Change A to D. Well, here's how you do it in SQL. You use the as keyword. So you say select first name as who, birth date as when. So you basically give them new names. And that is now going to create this table with these 2 columns. But now you change the names of the columns. Right? So that is the implementation of row in SQL. Okay. Be careful. There's a lot of things you can start doing wrong when you use software. You could think, okay, what if I try to give the same name? Surprisingly, it doesn't throw an error. I mean, if I had implemented it, I would have thrown an error, but surprisingly, it doesn't. It doesn't mean that it's a good idea, though. So you should really avoid doing these things. This is going to cause a lot of trouble along the way. It's probably using internally different names or renaming them in some way, or maybe creating who1, who2, you know, this sort of things. Just don't do it. don't do it. Be careful to always stick to the relational model that we studied with different names for every attributes, right? Okay, and the query plan here would just be it's a row in there. Okay, who is with me? Okay, so I'm not too fast. I think this is easy enough that that I don't need to stay long on them. But it's already 11, so let's take a break, 15 minutes. Go for some coffee, for a walk, something, and I'll see you in 15 minutes.